Hi and welcome to this video from the trigonometry section of the course, and you'll remember from year 1 we had trig identities which we used in the previous video, which was tan equals sine over cos and sine squared plus cos squared equals 1. As soon as you chuck the reciprocal trig functions into the mix, we're going to get some more identities that we can use, and so this video we're going to have a look at how those work. So essentially you can see from the bit I've bolded here, we're going to start off with our sine squared plus cos squared equals 1, and that's going to allow us to create two completely new identities, and then we'll have a look at how we can deal with equations and proofs and so on and so forth using those things. So here we go. We started off then, I said on the previous slide, we're going to use this, so let's do it. So there's our sine squared plus cos squared equals 1, and what I'm going to do now is take the entire equation, or the entire identity, and divide it by sine squared. There we go. Now, what have we got in each of our three bits? Sine over sine is 1, cos over sine, that's going to be cot, and 1 over sine is cosec. So what we end up with is 1 plus cot squared equals cosec squared. And there's our next identity, our rule that links together two of our 6 trig functions. Now the other one, we're going to get at it in exactly the same way, but instead of dividing by sine squared, we're going to do the same, but we're going to divide by cos squared. There we go. What's going to happen now? Well, here we've got sine over cos, which is tan, plus 1 over cos squared, that's going to be sec squared, and so there you go, there's your two identities. Now, if you've had a look at it, you'll know that the formula sheet that you get given for your exam gets much bigger for year 2. You get given a whole bunch of formulae, but these two are not ones that you get given. You have to know them, or in my case, I don't know them. What I do is rework them pretty much every time, because I can never get my head around which way round I do these and which ones are linked together. I'm pretty sure I know it, but it's a really simple job to rework them. It's a 5-second job in the exam, and I'll show you on the next slide how I tend to deal with those to save my poor brain from having to remember them. There are other trig things coming later on that are a bit more complex that you do get given on the formula sheet, but these two you absolutely don't get given. Okay, that said, let's crack on and have a look at how we go about solving this equation. So what we've got is a trig equation in terms of two ratios. We've got tan and I've got sec. So what we're going to do is get this whole thing in terms of sec, and so what I'm going to do is use the tan squared plus 1 equals sec squared. Simple bit of rearranging. Tan squared equals sec squared minus 1, so that's what I'm going to put in there. And there it is. And now all we've got to do is multiply the brackets and tidy it up. And there it is, tidied up. And I've also brought the 2 over, so we've got it as a quadratic equal to 0. And again, your choice, factorise quadratic formula, whack it into a calculator, whatever it is you do. I'd say I've factorised, and we end up with two solutions coming from here. So we've got sec 3 theta equals 2/3, and we've got sec 3 theta equals minus 2. Okay. Solutions. Well, we looked at the graphs of the reciprocal trig functions last time, and we know hopefully now that this one here won't have any solutions, so that kind of reduces our number of solutions, makes life a bit easier. Over on this side we've got sec 3 theta is minus 2, so let's turn that back into a sine, cos or tan, and in this case 1 over cos is sec, so we've got sec 3 theta equals minus a half, and if we have a look, we're going between 0 and pi. So we've got 3 theta equals 2 pi over 3, 4 pi over 3, keep going, 8 pi over 3, and 10 pi over 3. And then finally we've got to do the divide by 3, so we end up with theta equals 2 pi over 9, 4 pi over 9, 8 pi over 9, and 10 pi over 9. Now, if we have a look at that one, I always tend to go further than I need to. It might be you could have figured out quicker than me that this one on the end here was not needed. We've got a value that's bigger than pi, so I'm going to get rid of that one. It doesn't matter if you go more than you needed, but you have got to make sure you don't include any that are outside the range when it comes to the exam. So let's just make that disappear. And there you go. There's our 3 solutions to the equation. On we go. Here comes a trig identity. We had one in the last video. Here comes another one. We've got to prove that this fraction here turns into 1 minus 2 cos squared. Now, this is where I'm going to illustrate what I mean by kind of reworking them. I always take the kind of carve off the right-hand side of my paper where I'm working and just quickly rework them. This is just for you, just notes for for me to help figure it out, so I haven't got to be mathematically precise or formula how to do it. So sine squared plus cos squared equals 1. I know I'm looking at a cots, so I'm going to do a divide by sine squared, because that creates the cot there. And so I've got 1 plus cot squared equals cosec squared. And alongside that, I've got cot squared equals cosec squared minus 1. So just to kind of simply working with that, because that's going to allow me to replace the cot in here, and this 1 plus cot squared here is the cosec squared. So let's do all of that. There the two things are replaced on the top and the bottom. And let's do a bit of taking out the brackets. So I've got 1 minus minus 1. That's where the 2's coming from. And so we've got that. Now here we've got it as a fraction. And I'm going to just take this and write this as two separate fractions. So we've got 2 over cosec squared minus cosec squared over cosec squared. That bit's nice and easy. That's just going to be 1. This one here, 1 over cosec. That's going to be sine squared. So we've got 2 sine squared x minus 1. Now, all well and good, but if you have a look at the result that we're aiming for, we've got to come to 1 minus 2 cos squared. And the way to go about that, I suspect, will be to replace the sine squared with a 1 minus cos squared. So let's do that. So there we go, we've got 2 minus 1, that's okay, and then there you go, there's your 1 minus 2 cos squared, and there it is, all sorted. So it's just a case of, again, swapping things around, having a bit of a play, dealing with fractions, and again, up over here, just having a fiddle just to make sure that I've got my, my identities correct, and the result has popped out as we wanted.